Hello everyone, welcome to my class. In the world of statistics, as we know that not only correlation and regressions and chapters like mean, mode, median, measure of central tendencies, right? They are not only the common topics. Let's extend our horizon and try to see something deeper. We must learn about hypothesis. And whenever hypotheses come in our mind, usually one amazing and very simple test come in our mind is a Z test. So undoubtedly, our today's topic we will learn today in hypothesis, which is a very crucial aspect of research or statistics, is we will learn about a Z test. Basically, we will do two amazing things today. Is what is a Z test in statistics, and of course, we will compare a one sample Z test with a two sample Z test because they are the most common tests that are used in statistics. And not only that, we will solve an example and try to solve it, and that will make things very easy for us. So let's start learning what is a Z test. First thing you should always remember is that a Z test is a hypothesis test. And every hypothesis test use one field of statistics, that is inferential statistics. It means we try to say something about population, and we can only say something about population with the help of our samples. It means samples will predict about the population. Samples are the representative of the population. Are the sample true representators of the population? That is what answer is given by inferential statistics. And it is the field in which we use all the tests of hypothesis. And one very common test is that test. So that test is not only a hypothesis test, but it is one of the part of hypothesis test, that is it is a parametric test. Yes, and a parametric test is a test which only use a distribution which is normal. It means your population, your variable will be behaving in a normal way. For example, you took the height of students of a class. You know very well that some students have, very few students will be having very tall height, and very few students will be having very small height, but most of the students will revolve around an average height. This kind of data is actually a normal data, and Z test need that data, otherwise it will not give you a good result. And it is basically of three types. We have one sample Z test, we have two sample Z test, and we can also do one more test, that is proportion Z test. In our today's class, I will tell you about one sample Z test and two sample Z test, and we will avoid proportion Z test for our next class. So let's start learning the difference between one sample Z test and a two sample Z test. But before we start learning about a one sample Z test and two sample Z test, in order to compare before them, we must first learn about a one sample Z test, and let's start about it. Uh, for example, you believe so much that the height of all the Kazakhstan people is not 150 centimeters. You believe in this so much. What happened in research or what happened in hypothesis is that you have to put one more statement as a challenge in front of you, and one more statement that comes in challenge with you is very crucial to make. What you believe and what you are sure about, you call that statement an alternative hypothesis. But in order to find the right answer, whether you are right or another thing is right, you have to put one more statement as a challenge in front of you, and that statement is called as an alternate null hypothesis. Look at the statement. You put a challenge in front of you that average height of Kazakhstan people is only 150 centimeters. It means there are two statements fighting with each other. So, our purpose and the purpose is that you will take sample from Kazakhstan's people, and now you try to test both the tentative statements and see which one to trust. This is actually we do in hypothesis. We make two statements and try to challenge ourselves with the help of tests to see which one is more to believe. On the other side, let's see about a two sample Z test. Here also, you believe that the average height of Kazakhstan people is different from India's people. If you believe it, it's your alternative hypothesis. And on the same side, you put a challenge in front of you that average height of Kazakhstan people is same. Yes, it's same with India's people. And it's not different. And such statement becomes a null hypothesis. Now again what we will do, you will take sample from Kazakhstan people and you will take sample from India's people and you try to test both these statements. My question is that what did we observe? We observe that whenever we test any statement, we have to take samples. In both the tests, we took samples because it's inferential statistics, and in inferential statistics, we always take samples. Now, look at both these statements. We have one on the left, one on the right. What did we observe? What is the second thing we observe? We observe that in the first one sample Z test, in order to do a test Z test, we have to take only one population. We took Kazakhstan as a population and we are taking sample out of Kazakhstan's people. Now look at on the right side. We took two populations. That is the first difference between Z test and T test is that we took two populations. We have Kazakhstan people and we also have India's people. So the first difference between both the test is that in the first test we took only one sample. In the second test we took only one population. In the second test we took two populations. Let's try to learn it more further. So what I told you is that what a one sample Z test do is that if the sample mean is different from population mean of single population. I took samples. So what was my sample here? I took sample from the capital of Kazakhstan, and capital of Kazakhstan is Astana, and Astana was my sample. It means all the people of Astana will be my sample. City of Astana is my sample. You must learn one thing in Z test that you always take sample randomly. It means anything can be selected as a sample from the whole population of Kazakhstan. So, what is our null hypothesis and what is our alternative hypothesis? Our null hypothesis is very simple, is that the height of the people of Astana is same as the height of the people of whole Kazakhstan. And what will be our alternative hypothesis that we learned just right previously is that height of the people of Astana is not same as height of the people of Kazakhstan. And what we wanted to find out is that if the sample mean is different from the population mean or not. If it's different, alternative hypothesis will win. If it's same, alternative hypothesis will not win and you have to accept the null hypothesis. See, it's very simple. The more samples you take, the more they will be able to represent your population. If you lose, and if your alternative hypothesis lose, it's very much clear that you have to take more samples, or there was some problem with the data, or the samples are not true representative of the population. Now look at one more thing we have to learn between one sample Z test and two sample Z test is that Astana people should only be 30 or it should more be 30. You cannot take less than 30 people, otherwise that test is not recommended. One more thing one simple Z test need is that you must know Kazakhstan people height standard deviation. It means Kazakhstan was a population. So population standard deviation is must in one sample Z test. Now look at on that side. Here our situation is different. If the population mean of Kazakhstan is different from population mean of the height of people of India. Now you believe that height is different, but you have to put one more statement in front of you that height is same, right? So if the population mean height of people of Kazakhstan is different or not from the mean height of population of India, that is our question. So we make two statements. One in which I believe is that height is same, not same, and one is in which I believe that height is same. Height is same is a null hypothesis and height is not same is the alternative hypothesis. Now we took samples from Delhi. We took sample Delhi for India and we took sample whole Astana. Okay, and we took both the cities randomly. Yeah, that is a very cool point about Z test is that we whenever we take sample we take them randomly. Now from city of Delhi there are only 30 people or more, and city from Astana there will be 30 people or more. And you must know Kazakhstan people height standard deviation and India's people height standard deviation. So, what did we observe? We observed very clearly that we must need more than 30 sample. We must need population standard deviations. There on the one sample Z test, we only need one population standard deviation. And on the right side, in two sample Z tests, we need two population standard deviations. And our hypothesis is the very crucial part that we have to make. We must make two statements, null and alternative, as I have discussed with you. Now let's learn one more difference between one sample Z test and two sample Z test is basically their formula or their way of doing. Z test is equal to, you can see X bar, right? X bar is the sample means, it means city of Astana people average height minus the whole Kazakhstan people average height divided by sigma, that is popular standard deviation that you must need, and divided by the under root of the number of people you have taken. Either it can be 35, 36. As you know, you cannot take less than 30 to get a good result of this test. Now let's shift our energy towards the next two sample set tests. Here we have two population, right? So we have two mu, right? Mu are u type of this word, and mu 1 minus mu 2. They are population 1 minus population 2, and the x bar 1 is sample mean of the city of Delhi, and this sample mean of city of Astana is x bar 2 divided by under root of the square of the deviations, population standard deviation of the first population divided by number of people you have taken from city of Delhi, and plus square population standard deviation square divided by of the second population, that is India, divided by number of people you have taken from India's sample, that is city of Delhi, or I missed maybe Astana, right? Now let's learn about an example to learn this very clearly. Suppose a company claims that their two new smartphones have same average battery life. Okay, so company take challenge itself. Company believes that the average height of average battery life of two phones is same. The company take consumer group of 44 for the first phone, 40 from the second phone population. It means yes. What we are seeing here is that samples are more than 30 of two phones. Okay. One sample we took 44, one sample we took 40. And we tried to find the average battery life. The average battery life of the sample that we took was 28, and the average battery life was 25 of the second phone. The population standard deviation also is given of the first phone, that is 4.5, and the second phone population standard deviation is 3.2. Now, before we start learning, we do a hypothesis, we always have to believe in our samples. If you believe so much, you call that a very high level of confidence. But if you don't believe, you have to put that belief first, is that how much samples will not represent your population. So the chances that you can be wrong or your alternative hypothesis can be wrong, you have to put an alpha error in front of you, and that is, we will take a chance that only 5% chances that my sample will not represent the population. And that is called a significance level. And now first you have to choose this. Once you select this significance level, you have to make two hypotheses. The average battery life of their company's two smartphones is not different from each other. And what your samples try to prove is that average battery life of two smartphones is different from each other. You wanted to put that claim wrong. Basically, the example we are doing here is because we have two population, we have two smartphones. So what the kind of test we will do here is that we will do a Z test. That will be a two sample Z test. So we will collect data from the question. We have population standard deviation of two smartphones, 4.5 and 3.2. We will take sample size as well. The first smartphone samples were 44 phones, and the second smartphone samples were for only 40 phones. Now the population mean is said to be same, okay? Yes, our null hypothesis is that both smartphone have same average battery life. So population mean is equal. Our sample mean is 28 hours, and the sample mean of the second phone is 25 hours. Yes, we took 40 phone out and 40 phones from the second phone, and we take out the average battery life, and it was for 28 hours of the samples on the first phone, and the second phone was having average battery life of 25 hours. Now, if we continue with the question, we see that it's a two sample Z test, and we use formula and find two sample Z test statistics value. It is our next step, okay? And what we will do is that we will put the formula. Now the formula is very simple, that we put the sample mean, the average battery life, minus the sample mean of second smartphone average battery life, and divided by the population standard deviation of the first smartphone divided by number of samples we have taken on the first smartphone plus the population standard deviation of the second smartphone, and square divided by the number of samples we have taken for the second phone. What did we notice is that this formula is not exactly what I taught you. It's because the population mean of both the smartphone is claimed to be same. So there is no use of population mean, because population mean will be u minus u is 0. So we can take this only right formula here, and if we solve it, we will find the value as 3.57. Now what we will do is, our next step is to find a critical value. We always compare our test answers to a critical value in order to say which statement wins. Either null hypothesis win or either a alternative hypothesis win. We have to compare it with a critical value. Crossing a boundary of critical value means something win or lose. So we can also take one more thing to compare, is very famous in statistics, that is p-value. Now we can compare our test answer to both these values. We have selected a critical value here, and if you see that if you have 95% sample are representing your population, then you can take a critical value to reject or accept your null hypothesis as 1.96. In our question, we took a, a confidence that 95% sample will represent the population and 5% chances are there they will not. So if we have 95% confidence, you can take a critical value as 1.96. It's very common. We will compare a critical value to our z-test statistical value. And when we compare the critical value or p-value to a sample z-test statistics value, what we find out? See, if your z-test statistic value is greater than the critical value, you will always believe that your alternative hypothesis is right. If your z-test statistics value is less than the critical value, you will always believe that null hypothesis is right and you cannot reject it. It is more close to right, you cannot reject it. But what happens with the p-value is completely opposite. With p-value, z-test answer, if z-test answer is greater than the p-value, you cannot reject the null hypothesis. If z-test answer comes less than the p-value, you can reject the null hypothesis. So here our answer was 3.57 and we compare it with 1.96. When we compare a z-test with a critical value, what we find out is that z-test answer was higher than the critical value. It means we will accept our null hypothesis, or you can say we can reject the null hypothesis. Never say you accept the null alternative hypothesis. You should always say I reject the null hypothesis. So what we will do, we will reject the null hypothesis and we can easily say that the population mean of the first smartphone average battery life is not different, is different from the average battery life of the second phone. They are not same, they are different. So after doing all these steps, this is the way we find out and make our decision in a Z test. We have to completely remember one thing is that we have to follow the same procedure for one sample Z test as well. Only thing that will change is our hypothesis, and only thing that will change is that our formula will change. Everything else will be same. But before we move further, let me ask you one thing is that the company said that the average battery life of two phone is same. But your samples, when you challenge them with your population, the story was little different. The average battery life of two smartphones were not same as per our decision. So always believe in one thing is that company can claim three situations. First, it can say that the first smartphone average battery life and second smartphone average battery life is same. If they are same, you should, right? And if company can also say the population mean of first smartphone can be greater, they can say that it is greater than the second smartphone. A company can claim one more situation is that population mean of first smartphone is less than the second smartphone. So we have three situations that a company can claim. If the first situation exists, you should use this formula. If second situation exists, you have to believe one thing is the population of the first smartphone is greater than the second smartphone. You have to use mu1 minus mu2. This is population and mean. You have to use this in your formula. Now second situation as well, third situation as well, we can use mu minus the mu2, the first smartphone minus second smartphone. But only in the first situation there's no use of mu, because if you minus same population mean, it will obviously be a zero. So this was our question actually, and this is how we completely analyze this question, and that is how we understand today that what is the Z test, and what is the difference between a one sample and two sample Z test, which are very popular in statistics. And next time when we will meet, right, we will understand about the comparison of a Z test and T test, which is a very minor difference. So thank you so much everyone for listening to the lecture. I hope to see you in the next video on our Z test and T test comparison. Thank you.